So we always start off by factoring things completely. The bottom is a difference of squares. And so step number one, we list our non-permissible values. X can equal 1, x can equal -1. Are they vertical asymptotes, or are they holes, or are they sum of each? This is a hole. We know that it's a hole because these would cancel out. The x plus 1 on the bottom doesn't cancel out, so this one will be a vertical asymptote. The vertical asymptote will be at x equals -1. The hole, we need to figure out, it's going to be at 1 comma something. Now to figure out what the y coordinate of that is, we can simplify this. Since our x minus 1's canceled out, this equation becomes y equals, and this is where you have to be careful, because sometimes you'll want to just write x plus 1. But that x plus 1 is on the bottom of our fraction. It has to stay on the bottom of our fraction. What would be on the top of our fraction? A 1. Because when we simplify things and everything is gone, there's going to be a 1 left. Now, looking at this new equation after it's been simplified, you can figure out the coordinates of your hole. When x is 1, what would y be? 1/2. Step number 2. Whenever you have a hole in your graph, when you're going through step 2 to figure out oblique asymptotes or horizontal asymptotes, you can now use your simplified version to find out what kind of asymptotes there's going to be. Because sometimes, and we've seen it in the past, we simplify things and we end up with a line. And if you end up with a line, you could graph that line right away with the hole in it, and you wouldn't have to worry about any other asymptotes because you know how to graph a line. In this case, we're left with a rational graph still, 1 over x plus 1. So in looking at that, to figure out about oblique asymptotes and horizontal asymptotes, we look at the highest power or the highest degree, and in this one it's an x. We have 1x on the bottom and no x's on top. What does this simplify to? 0. And anytime this simplifies to a number, we will have a horizontal asymptote at that value. Now that we've completed all of our stuff with asymptotes, we can start our graph. We know that we have a vertical asymptote at x equals -1. We have a horizontal asymptote at y equals 0, and we have a hole at 1 comma 1/2. Let's just, there we go, that looks better. So we have a point in this section of our graph. We can now figure out, do we have any, what are our x-intercepts and y-intercepts? For our y-intercept, plug in 0 for x. Can you see that if you have -1 over -1, you're going to have a y-intercept at 1. For our x-intercepts, your x-intercepts are when your numerator is equal to 0. Again, we'll use our simplified form. When is 1 equal to 0? Never. Good. So we have no x-intercepts. So again, you're not looking here anymore because that canceled out. And that one was one of our non-permissible values. Drawing this, we have this second section, we have enough information in here to draw our graph. We don't have any information in this section, so we're going to pick a value. Let's use -2. If you plug in -2 into our new simplified equation, can you see that you'll get 1 over negative 1, which will give us the point negative 2, negative 1. And now that we have a point in this section, we can draw this graph as well. Now, I drew this graph using the techniques that we've been developing. Okay? But in this blue square, this 1 over x plus 1, we could have also drawn this using what we learned in Chapter 3. What's our parent graph? Is a 1 over x graph. What kind of transformation would this be? Transformation 1 to the left. Can you see that in our final graph? That we've just drawn a 1 over x graph, moved 1 to the left. The only thing about this 1 over x graph is it has an added hole to it, because we have a hole at 1 comma 1/2.